Welcome to my talk, A Binary Analysis of Real-World Desktop Apps with Frida. My name is Kyle Ossinger. I'm a senior security researcher at Cisco ASIG, where I take apart Cisco applications and find vulnerabilities. And I have a focus on binary applications and exploitation. In my free time, I like doing a lot of reverse engineering. We don't really get a chance at work since we mostly have source code. So I particularly focus on automation and finding new techniques and tooling to speed up finding vulnerabilities. So one thing I've started using a lot of is Frida, and I just wanted to go over a little bit of like some basics to get you started using Frida as well, because I think it's really a great tool for digging deep into proprietary closed source software. So in this talk, I'll go over what is Frida, why you want to use it. I'll go a little bit over installation and tool setup, but I've sent a message that has all the information about how to do that on your own as well. And this talk should be recorded, so you should be able to follow along later if you don't get a chance now. I'll also go over the basic usage of Frida's tools that come with it, such as frida-trace, but then dig more into the Frida REPL and then scripting that REPL with some standalone JavaScript. And we'll get a little bit more advanced as we go along with some incremental sort of discoveries of the program that we're targeting and the function that we're looking at. And then I'll wrap up with some next steps you could use with the knowledge that you've gained. Cool. So what is Frida? So Frida is a dynamic binary instrumentation tool. So I'll use the word instrument or instrumentation a lot throughout this talk. And what I mean by that is essentially adding, modifying, or removing functionality and instructions at a certain level in the program. And so there's a lot of other DBI tools out there I'll go over, but Frida has bindings for Python, Node.js, C, QML, and Swift. So you can get started making tools with it with any of those. It's pretty easy to start. It's got a really well-documented API that I also sent a link for and that I'll also show a little bit during this. It has features such as hooking functions and instructions by address or by symbol name. You can perform basic block and instruction level tracing, and you can add instrumentation to programs at the instruction or function level. And you can even put C functions or JavaScript functions into the program, and they'll execute at the places that you specified. So all of this kind of makes it kind of like a dev tools for native programs. So why would you use it over other DBIs? So a lot of people that are really into dynamic binary instrumentation would say that Frida is not a true DBI because there's some features that it's missing. So like things like having events for modules that get loaded and being able to do things with those events doesn't have those. I'm not sure exactly what else because I haven't dug much into Dynamo-Rio or Pin, but I've used them a little bit. And from what I can gather, the big difference between Frida and those is that while those might be a little bit more robust, they are really slow to get started on it. It's really hard to prototype tools with Dynamo-Rio and Pin. There's a lot of groundwork that you have to do to get things started with them. And so Frida makes it so that you can just very quickly like write a few lines, see them working right away, and be like, okay, I think the idea has some merit to it. I'm going to go with this and flesh out a tool for it. So another similar tool is like debugging, like a debugger. It's not really geared for automation though. It's more for stepping through the programs. Then you could also just do your own kind of library injection if you wanted to put some debug statements into a program, but it's not very portable. Like if you write a shared object for Linux and then you try to drag that over to Windows, it's not going to be very easy to do that. There's probably going to be a lot of specific flags you have to enable and defines. Yeah, it's just slower to develop generally, and you won't have as much of a feature set available to you like right away. Okay, so I sent instructions for how to get things started with Frida on the Room 2 channel. But just to quickly, like, the most important thing is if you're on OS X, you have to disable system integrity protection while you're doing it, because that prevents processes from attaching to and injecting code into other processes. So it's something where if you don't really want to do this on a laptop that you care too much about, like sensitive data, usually it's like you turn this off, do your testing, and then turn it back on if that's the case, or just use a test laptop. I have some Ghidra instructions that I can pass along after the talk. Essentially, it's just kind of to go along with this, so you can see what these functions look like in a disassembler, and how that matches up to how you would use them with Frida. So if once I send the archive later on, in Ghidra you just basically import that with a restore project menu item, and I'll send that GAR file, and it'll just basically import the project from Ghidra. The target installation. So since I'm at Cisco, I'm constantly having to use WebEx, and I tend to just go after any application that I constantly have to use. So WebEx was the natural option for me. I got permission from everyone to go over it. There's no vulnerabilities I'm discussing, but basically it's an end-to-end encrypted messenger on it, and so you can't peek at messages with Wireshark or with Burp or anything like that, and so you have to, in order to actually see the messages being sent to the other end, you'd have to inject into the process and get to the message that way. And so that's what we'll kind of be doing with Frida. We'll look at the messages before they're end-to-end encrypted, and then we can peek at those and tamper them, whatever we want. The slide here, just if you're going to be doing this stuff, it's a good idea to have a tab open with JavaScript API for Frida, just because it's a really helpful resource. All right. So as a security researcher, when I'm looking at a program, I always try to find interesting features that seem like they have a lot of complexity. They take a lot of user input. They're probably doing a lot of things with that user input, because that's where I find the most juicy bugs, I guess. And so the natural place I went to first was the message processing. So when I go into the messenger, I see that there's two different ways to format text. There's the rich text formatting, and then there's markdown formatting. And since Markdown's a little bit newer to the program, I decided I was going to dig into that. So I enabled that in the program, and I started messing with it with Frida. So to get started, and I'm hoping this works. Let's see. Yay, okay. And let me make sure I can get back to. Oh, uh-oh. Can I not return to my slides? I was stuck in the terminal forever. I will figure that out. Anyways, for now, to get started, I'm going to make that a lot bigger. Is that visible for people, or is that good? Okay, so to get started, basically, I happen to know that this program, some of the libraries have symbols enabled, so it makes it a little bit easier to mess with and to debug. And so I searched for Markdown with the -S for symbol flag, and I put wildcards around it, so it should find any function that contains the word Markdown in its name, and then the name of the function that I'm going to be testing. And so I have that running right now. I have WebEx running. Let's see, oh, right, frida-trace. And so it says ambiguous name. So a lot of these programs will have multiple processes running because they have like a renderer, and then they have the actual main process. So I'm just going to try each one and see if it's got some interesting functions. Okay, it's got a ton of functions. All right, and so I guess you can't see it. It's a little hard to share all the different apps I have open, but I have the WebEx app open. I'm sending a message right now that just says hi. And you can see up at the top there that a bunch of output came out. So that's basically the output from all the different hooks being called on all the functions that are being hooked inside the program. And so that's a start. And you can look at all those that were created by looking in the handlers directory that Frida just created inside the current working directory. So if we look in there, we can see it created a bunch of directories based on shared objects that are inside the program, and then the next to it is a JavaScript file that pertains to the function that was being hooked inside that library. And so the one that interests me here is this one. Looks interesting because it seems like it's markdown to HTML. It says so. It sounds like it's something that's going to be taking markdown text and turning it into HTML text, and so, or taking a markdown object and turning it into an HTML object. So that sounds interesting to me because there could be a lot of complexity there with turning one format into another, especially with HTML formatting and things like that. And so that's the one I decided to dig into. So to get rid of all these handlers I don't care about, I'm just going to RF that. And then I'll rerun the frida-trace with a more specific markdown to HTML. This should just create one handler. And then okay, cool. Yeah, we created the one handler, and then if I go back over here, I send another hi message. I see two calls. So it calls it twice. That's because it's calling this when you are sending the function. So it's converting your markdown to HTML, I believe, when you're sending it, and it's also converting it or calling this function when you're receiving a message. It was a little strange, but I verified that by using the web client and sending a message to myself with that, and I saw that it only called it once. So it seems like it's calling it on send and receive. All right, cool. So let me see if I can get the demo gods to let me have my presentation back. There we go. All right. So it created all these handler files. As an aside, if your target program doesn't have symbols, you can still hook exported functions with -i and the export name. So like if you're looking at a server and you know that it calls receive, you can do -i receive, and it will probably hook libc receive, and it'll show you output from that. Create hook files for you for that. Also, if you're using a disassembler, this is something I do all the time, where I have a target program that has no symbols or anything, like a giant program, and but in my disassembler, I found something that looks interesting, and I kind of understand what arguments it takes, and so I just find the offset to that in the disassembler and give it the module bang offset, and it will hook it that way, and you can start messing with it with Frida. All right. Cool. So inside the handler file is basically just a JavaScript object. Inside the object is two functions. There's onEnter that takes, basically it captures the arguments that were sent to the function that's being hooked. And then there's onLeave that captures the return value before it ends the function. And so inside these functions, you can add any of your logic you want to do. You can look at the arguments, you can modify the arguments, you can save values to the this object and then reference them in the onLeave object if that's something you need to do. So one of the basic things we might want to do is just to get a backtrace. So this is useful because if you're looking at a proprietary software, it helps give you some context of what's calling this function and things like that. You're probably familiar with call stacks already, but basically this is doing the same idea. So you can do thread.backtrace. These constants are all explained in the JavaScript API. It's pretty well documented. But basically it just needs a context object, which is always going to be in this.context in the onEnter function. And then backtracer.accurate is the default. If you leave that out, it's just going to put that in anyways. And so then I'm going to map debug symbol.from address to get, this is just going to basically get the debug symbol name for the address in the call stack. So it's going to symbolize all those addresses, and then just make it look better with a join with a new line. So I'll do that real quick. So if you see in this, in the handlers, go into here, and this is the default handler that it created for me. It's just like a log statement showing the name of the function. I can add a log here that's doing the backtracer or thread.backtrace, this.context, tracer accurate, and see what that looks like. Frida. Make sure this is 6195. Okay. And so now if I send a message in the target app, now I see this long list of pointers. And so that's basically the call stack. And like I was saying, you can just go up back to the handler here, map debug symbol from address. Oh, my head doesn't turn that far. Okay. All right, and then I sent hi again, and now you see, so like it's kind of nice that the REPL for Frida is just like automatically updating. So when I'm changing that file, it automatically adds the changes here. So now looking, all right, back here, we can see all the different functions that are being called, or that basically the functions that called markdown to HTML starting. So like this is the markdown to HTML call, and then after this is what called that, and what called that, and what called that, and so on. It's a call stack. So that can help me figure out if I'm hooking the right function, or if there's something farther up the call stack I should probably be hooking, because this is like a little bit too far down. So another thing we can do is use the Frida REPL. So instead of using frida-trace to generate hooks, we can just kind of try out API functions here. So this is good for learning how things work with Frida. So you can go down here, and instead of doing frida-trace, you use the same PID and just do Frida. And now you're just dropped into a REPL interface. And it has autocomplete, so you can just try things out. So one thing you might want to try is like, I don't know, debug symbol, find functions matching. And we can kind of get the same functionality that frida-trace was doing here by doing this. So this will find any debug symbols that have names matching that glob. And so it'll kind of spit out anything it found there as a list. Sometimes it takes a little bit. Okay, cool. Yeah, so there's the address of the function that we're interested in. So it's really good for just trying out API functions that you're not really familiar with how they work. So outside of that, there's standalone scripting. So this is essentially just automating the REPL. And this allows you also to make some more powerful tooling. So the frida-trace is kind of constricting you to being inside of a hook. And so you can only do things that are inside that onEnter or onLeave functions. The standalone scripting lets you do things outside of those. So for instance, you can define functions, like you can take an address of the program, like say you found some function you're interested in and you want to call that function. You can actually define that as a native function inside the JavaScript and then call that separately. So like that might be useful for things like fuzzing, where you can define the function you're interested in fuzzing and then call that over and over again with different inputs from Frida. So it's basically the first step in making a standalone tool. You can even instrument basic block and instructions with it. And you can make things faster by, there's a C module API inside of Frida that lets you, instead of making JavaScript hooks, you can actually make a C-based hook to speed things up. So there's a little bit of like craziness going on with like injecting JavaScript that also injects C, that also, I don't know, it's like lots of onions, but it definitely helps with performance on those hot hooks. So let's, as an exercise, let's re-implement frida-trace using a standalone script. So with the Frida API, there's this object called interceptor. And the interceptor implements attach and replace. And attach is basically doing the same thing that frida-trace was doing, where it's creating an object that has an on-enter and an on-leave hooks. And replace is doing something a little stranger, where you can actually replace a function like at the address that it's usually loaded at with a JavaScript function or with a C module function. And so this is useful as a security researcher when I'm going after some program that it has a lot of client-side checking, and it's saying, oh no, I'm totally protecting the server by saying not allowing the user to send this data with their messages. And I just replace that with a no-op, or replace it with something that gives me back the same string that I sent it, instead of removing things. And so that would look like this. Like this is basically frida-trace as a standalone program. So you can see let sim equals is like sim is going to have the address to markdown to HTML function, and then we're passing that address to interceptor.attach, and then giving it the object that has onEnter and onLeave functions. Yeah, and so one thing we might want to try is now that we've gotten the functions that called our target function, we can also see what functions our target function calls. And so this can be useful for things like if you know that somewhere in your function they're doing some sort of sanitization of your user input, you can find those calls and then nop them out, basically. And so here we use a powerful module called Stalker that in the Frida API, where you can, it's an instrumentation library, and you can use it to do code tracing. So you give it the thread ID. In this case, I'm doing it inside of a hook. So inside the hook, I'm telling it to start tracing at the beginning of the function. And basically, it has the events there where you specify what kind of events you care about during the code tracing. So there's all sorts of different events, but we're only concerned with all the calls that the function is making. So anytime a call happens, it's going to report back. And then we have an on-call summary function that we specify here that will take a summary object that just has the address of what was called as the key, and then as the value, it has how many times it was called. So that can be also useful if you're trying to trace down performance issues, for instance. And so I'm just using JSON.stringify to show those right now. I'll see if I can bring that up. Yeah, so this is kind of what that looks like here, just like in my slide. Except I'm going to do something different here, actually. Instead of using JSON.stringify, I don't care too much about how many times each function was called. I just care about the names of the functions. And so I just have it spitting out the names of each function that was called. And so now back in the WebEx app, when I send another message, you can see now it's putting out what functions were called from the target function. Okay, we must. There we go. Yeah, so you can see it's doing a lot of HTML parsing here. It's using CMark, Houdini to escape HTML. So that might be something I want to nop out at some point. So it gives you some ideas when you're looking at a target function. And it's really important also that when you're using Stalker inside of a hook like this, that you call unfollow at the onLeave function, because otherwise this is just going to keep code tracing forever, even after the hook is done. And then if the hook is called again, it'll start following again. There'll be probably a race condition or something. It's probably just going to crash. And so I mentioned that the events, there's a few different types of events besides call. There's ret for anytime a ret is encountered, it's just going to report back. There's exec, which is really noisy. Every single instruction that happens, it's going to report back about the instruction. There's block, which is useful for fuzzing. So you can say every time a basic block is encountered, I want to know about it and where it happened and stuff like that. So you can do things like with AFL, you can basically keep track of coverage like that. And there's also compile. So I mentioned that Stalker is an instrumentation engine. So the way it's kind of working is every time it encounters a new basic block, instead of just letting the basic block execute, it copies the instructions over to like kind of a shadow basic block, like a new basic block. And any instrumentation it needs to add, it adds to that, and then it jumps to that new instrumented basic block instead of the original one. And so this compile event is basically saying, let me know when a new basic block is encountered and when the instrumentation is taking effect. And so that can be useful for coverage data. So like if you're just trying to see what basic blocks were hit at all, this is going to show you on each first time a basic block is hit, it'll let you know. And one of the most powerful things with Stalker is the transform function. So transform lets you control the instrumentation that Stalker does. So it gives you an iterator for instructions, and so you can go through each instruction and do things like, oh, if it's a call, then do this. If it's a jump, do this. Like you can change instructions, you can add instructions, you can remove instructions, all that. And so it just really is very powerful. It's a lot faster than doing things like there's like it's a lot faster than hooks, for example. Like there's an implementation of an AFL fuzzer written with Frida, and they basically use this to push instructions into each basic block that keep track of what basic block was hit before this and what basic block address this is, and keeps track of the map of coverage inside the program. Yeah, it's definitely my favorite part of Frida. Yeah, and so the next step, I think, so look, now that we've got call stacks and we've got call traces from the function and to the function, the next thing I'd want to do is look at what arguments are being sent to the function and what kinds of arguments, and if we can control those or look at them or change them, whatever. So that's something I'll do next. So if we look at handlers, if we look at the handler, we can see up at the top there, hopefully this is visible, I'll highlight it to hopefully make it more visible. The type of argument it's taking is standard basic string. It essentially seems like it's a standard string, or basic string in C++. And let's see if I can bring this over. So if we wanted to, I guess I can't bring that over. So basically, when I'm looking at how to get things out of objects that I don't have easy ways of doing that with, like I can't just take this string object and say like read it like a C string, because it's not going to work, because a standard string in C++ is implemented a lot differently. So what I do is I go to cppreference.com or anywhere like that and look up the member functions and things like that. For example, if I want to get at the backing C string, there's a function in the standard string implementation called C_string, and so I can use that. If I can find somewhere in the function, somewhere in the program rather, that calls the C string member function. So let me see. Scripts, something. Scripts. Sorry about that. Okay, so I'll use this one. So this is the most basic hook. For now, I think I just want to use the REPL. So I'll use, basically I can just use debug symbol dot find functions matching, and first I'll do the markdown one, just because I need that type. And then I'll get the name from it. So from address. So this should spit out the full name with the type information and everything, and then I can use that that type information as another wildcard to see functions that are using that type, and or functions that branch off of that type. So for example, like string.cstring. I'm not sure why it's taking a while. Like sometimes this target application can be pretty slow. Okay, it's got tons of libraries. Alright, there's my cursor. So this is the type information, so I'll just take this whole thing, except for the const pointer at the end there, and look for functions that are using that type. So I want things that start, I'm not going to have the first wildcard because I want things that start with that, but I'm going to have the end there. And I know that it should end with a : C _ string. And then I don't know what comes after that. I'm just going to go for it. All right, and it came back with this. So let me see if I can do debug symbol dot from main. Make sure that it's all working. It should give me like the full debug information, and then from that I can grab the address. Yeah. So you grab the address from that, and I'll just copy this into our program to speed things up a bit. So now we can define up here some helper functions. So we're going to say cstrings address equals this. Let's see, do I have a quote or something? Oh, it's a new line. Okay. All right, so that's the address, and then I can make that callable now by defining a new native function and give it the address, and then the return type. These are all defined in the JavaScript API as well, and then an array of the argument types that it expects. So I think this should just expect a pointer to a basic string, which should just be basically like the this pointer. So now, inside the hook, instead of just printing out like a pointer or something, we can have it print out, hopefully, the string. So if I do -L scripts first, and then go back into WebEx app and type a message, it still does a pointer, and that is because the C string still it doesn't, like C string is going to return the pointer to the backing C string. So from this I have to call .read UTF-8 string, and that will give me the actual string. So there we go. Now it's just showing hi. So it's just getting whatever string I'm passing to this function. And so now we have a little bit more control over the program, right? So we can look at the string that's being sent, and that's the first step in being able to modify things. So from there, we would want to define things like being able to assign things to the string, and being able to create. Sorry, I thought this was over here. So being able to assign data or new strings to that string object, and being able to make new string objects altogether. And so that the reason we would want to do the third one is because that's what we would need for actually calling this function, because we need to create some basic strings to give to the function as an argument. And so that's what we'll do next. Here. So show this. What is that? All right, and so I'm just gonna skip ahead here a little bit to show. Basically, I did the same process as before, where I found the C string address, except I did it with a few more addresses. So I got the address of the constructor here, which I named bstar new address, and then bstar new, and basically define it the same way. It takes or it returns a pointer to a basic string object. It takes a pointer to the basic string objects. It returns just a pointer. I'll go over that later. It takes the pointer to a basic string object, and then also the pointer to a C string. And I've also defined our function, our target function here, as something that returns a pointer, and then takes 2 pointers as well. It seems like it should take 1 pointer, but in practice, it seems calling it needs 2. Don't know why. So I haven't gotten that far in reversing it. But so basically, we run this like I could basically re-implemented the functionality of this function inside of JavaScript now. So I've got a payload here. It's a C string, it's a JavaScript string, which I'm then making into an actual C string that's allocated in memory right here. I'm doing memory.alloc UTF-8 string and putting the payload in there. I'm creating a basic string object. So I didn't take the time to reverse engineer the basic string object like to see how big it should be. I just did 1024 plus the payload.length to be safe. And then you can call basic string new, which creates the basic string object with that string as the payload. And then I hex dump that just to show what's going on. And then I can call markdown to HTML with the payload basic string just twice. It really got upset when I sent it once. So, and then I show the result. So I will get out of this. Bring it down to the 4th one. Sorry, it's taking a while. Okay. So we can see here that it's failed to load script actually. I'm going to restart the WebEx app. One thing I've found with Frida that is a little bit annoying is that it seems to cause a little bit of memory leaking in the target program. So it's good to just restart it every now and then. Let's find the PID again. All right, cool. So I'll kind of walk through this here. All right, so it attaches. We've created our payload string. This is it as a string object in the hex dump. So you can see it's not just, it has the hello part with the stars around it, but it also has this byte here, the hex 12, and it seems like that's about it. And so, yeah, the basic string, when, like, I guess just not meaning to, but I kind of reverse engineer this as I'm going along. Like, I can see that when the string is very short, it does a very basic representation of it, where it just has kind of a length field and then the string itself. And but when the string is rather long, like I'll send a longer string, just a bunch of A's. You should see over here that once it loads. Oh right, I'm doing this from. I forgot that I'm not actually hooking it. I'm sending the string myself now, so I just put it over here. So just a longer string, just to show what I'm talking about here. Save this. Now it should update over here in a second. Okay. So now we can see, if we go up here, it's a little bit harder to decipher the string now because the plain text isn't there because it's too big to hold in the small buffer, so it's actually allocated elsewhere. And anyway, that's just kind of what I was talking about, where like if you hex dump these objects as you go along, you kind of learn how they work. But the intent of my program is kind of finished here, where I've got a way to call the target function with the proper arguments, and I can see the output now as well with it's turned into HTML. And so this lets me do a lot of introspection now with the target program. I can try different payloads that are problematic, like I found like with a bunch of these backticks and then putting something in here, like derp. You just, once it reloads, I saw that had some sort of special functionality. So as you see here, it turned it into a code block. Like it's pretty standard with a lot of these like markdown implementations, where they'll actually try to show you a code in a specific language that you specify, but it has some quirks. Like if you do that, you can put things in there you shouldn't be able to. So I had script, and you'll see that it actually you should just like remove that or put HTML entities or something around that when it reloads. Yeah, so it's got HTML entities around it. But what I was seeing in the client was that it would show up for like a split second. And so I think there's some discrepancy between like the rendering and the parsing in this markdown to HTML function. So that was kind of where I've been focusing for a little bit in my research. So yeah, basically we've created that function. We're able to call it, test things out. Next possibility is what you'd want to do. Or what I did rather was to set up a fuzzer for this target function with AFL++. It has a Frida mode. So you can basically take your Frida script that you created and feed it to this AFL plus fuzzer, and it will call it very quickly over and over again and keep track of coverage data, and that will kind of determine what inputs it sends next. And you can also find functions closer to the network sending functions if you're worried that there's a lot of like censorship or sanitization happening earlier on in the process. If you're trying to send malicious inputs, for example, you can look at the receiving functions instead of the sending functions. That might be interesting for more rendering stuff. Like we looked at markdown to HTML, but what about the HTML parsing itself? There can be a lot of issues there if their HTML engine is glitchy. and yeah, find out any client-side checks and knock them out with interceptor.replace. So to go over what we covered here, we went over what Frida is, what it does, why you should use it. We covered how to go from a UI feature that we were just a little bit interested in to instrumenting the code that's responsible for making it work, and looked at enumerating the callers and callees of that function with backtrace and stalker, and how to make the function callable and ready for fuzzing. And before I end it, so it's better when you're doing dev work with Frida to use this Frida agent example. It uses TypeScript instead of JavaScript, so there's bindings, and so you can actually like have autocomplete and what's it called, IntelliSense and stuff like that. That really helps when you're making these things, and it's also a little bit neater. It compiles down to a JavaScript file. Yeah, VS Code is pretty good with it. I'm sure there's some other engines that work well with it. It uses NPM, but yeah. It also allows for modules, and one I'll be releasing probably this week is one that allows you to sync disassembler with Frida using, there's a tool called RETSync already that lets you sync debuggers like GDB with your disassembler like Ghidra or IdaPro. But I'm doing the same thing for Frida now. So you could do things like if you have some functions that you've renamed in your inside your disassembler, Frida can, or you can use Frida to look up those functions by the names you defined and get the address to them. So you can like hook functions that otherwise wouldn't have symbols. Yeah. So I don't know if there's any questions. It's kind of a whirlwind too. Yeah. So yeah, you don't need source code. You don't need symbols. So like I was saying at the beginning of the talk, there's you can find if you don't have symbols, you can hook exported functions, or you can use a disassembler and look at the functions in the disassembler. And when you find something interesting, you can take the offset to that function from the disassembler and feed it to frida-trace or Frida or anything like that. So you can hook things based on the function offset as well. You can even hook things that aren't functions. So you can hook like an arbitrary address as well, which can sometimes be interesting. Yeah. Well, the way like it works because like ASLR is basically randomizing the base of the pointer, but the offsets should remain the same. So it's just Frida is keeping track of the modules that are loaded and their base addresses, and so you just add the you can see the base address and then add the offset to those. Yep. Yeah. Yes. Yep. You can execute files as well. So let's see. Actually, I can show that. So if I get out of this, I can do frida-trace-i for exported function and do like open. So it's going to hook any open calls. I'll do cat etc password. All right, you have to give the whole path because otherwise it will think that it's a service that's running. And so you can see it. I'll go up to the top. Oh boy, OSX is a really big password file. Okay, so you can see it ran bin cat and created a handler for libsystem kernel.dylib/open. And so you can see the regular standard output here, and then later on, once the giant file is done, oh my god. Okay, then you can see the Frida had hooked open, and since open is a like sort of standard library function, Frida already has definitions for what arguments it expects, and so it prints those out pretty helpfully here, like an S-trace or L-trace format. So you can see the file that was opened and the flags it was opened with. So yeah, you can definitely execute files and hook. Okay. Oh no, sorry. I thought you were talking about if you just have to hook running processes, or if it's like you can run the processes yourself. No, it's not. It's definitely a dynamic binary instrumentation tool. For static analysis, let's see. I mostly just use like scripts I've written for IDA Pro or Ghidra, things like that for static analysis. Um, yeah. Which the bottom? Yeah. Yes, that was just hooking the open export, and then dash dash just so that it doesn't think anything else is a Frida option, and then bin cat argument. Great. Yeah, there's no other questions. Thank you.